All right, so today we're going to do finding missing angles in a right triangle. And essentially, this will be the last new thing we learn. And then we'll do some practice on next Monday. And then next Thursday will be your final quiz. And then we'll just be reviewing things to try and get people's grades up for the rest of the year. So this is the last new thing we'll learn. And then we'll do some practice. And then we'll focus on getting all those grades up if we need to. All right, so we're going to be finding the missing angles in a right triangle. We last were looking for the missing side lengths using our trigonometry. This time we're going to be looking for the missing angle, and it's almost the exact same thing. There's just one extra button we push on the calculator to get it done. So, first things first, we're going to have our normal right triangle, like that. Okay, we're going to have some missing angle now. So for instance, this angle here is our theta, and we're not going to know what that is. But we are going to know at least two side lengths. So for instance, if this is a 10 and this is an 8, we can now find this missing angle. Again, we need to figure out of the three trig ratios, are we going to use sine, cosine, or tangent? And so we're going to go back to our sine of theta is the opposite over the hypotenuse. Cosine of theta, if you remember, is our adjacent side over the hypotenuse. And tangent of theta is our opposite over adjacent. So we're going to use these ratios again, and then we're going to tweak one little thing in it so we can find out what theta is. So let's go back to the example here. So if I look here, this is my reference angle, and that means that 10 is my hypotenuse because it's opposite of the 90 degrees, and 8 is the adjacent because it's attached to that reference angle. Over here would be my opposite side, but we don't have any details on that, so we can't use opposite. So if we look at this problem here, we're looking at the hypotenuse and the adjacent, and the only one that deals with the hypotenuse and the adjacent is cosine. So we're going to be using cosine for this. So to solve for it, we're going to say we have cosine of theta equals 8 over 10. Okay? So we need to figure out how do we get theta all by itself. Well, this is where on the calculator there's special buttons. So on the calculator, we have what we call our inverse trig ratios. And the inverse trig ratios are going to be the things that undo our problem to give us the angle. Okay, and so where to find these? Step one is you're always going to have to hit second. So we hit the second button. And step two is to find the trig ratio you want. So whether it's sine, cosine, or tangent, whichever one of those buttons we're using. And then you should see either sine to the -1, cosine to the -1, or tangent to the -1 power in your calculator screen. This is what we want to see. These are the inverse trig ratios. Okay? So when we're all said and done, this is what we want on our calculator, is one of those three. Okay? And this is how you get to it. So on my calculator, if I hit second cosine, I'm going to get cosine -1. And then since I'm trying to find theta, all I have to do is put in 8 over 10 next to that cosine -1, and that's going to give me my angle theta. And so if we're looking at this problem here, let me grab my calculator. We're going to do second cosine. There goes my cosine -1 showing up on my screen. And then I'm going to put 8 divided by 10 in there and hit enter. And it gives me an angle of 36.87 degrees. And so that's what my missing angle is. There really isn't any algebra stuff that we have to do on this stuff. The calculator is going to do all the work for us. All we have to do is make sure that we've assigned the opposite, adjacent, and hypotenuse correctly and chosen the right of the right trig ratio. So in this case, like we said, it would have been cosine because we have adjacent and hypotenuse. We plug that into the calculator with the inverse trig sign. Then we plug in the ratio that we got, and that'll spit out our degrees. So let's do a couple practice problems here. So there's one right triangle. Oops. Another right triangle. And on this one here, we're going to have the side lengths of 6 and 10. And our missing angle is going to be here. So we'll call that our theta. On here, we're going to have our missing angle. And we're going to have a side length of 6, and this will be 17. So let's first start by assigning them their correct names. So if this is my reference angle, then 10 is going to be my opposite side, and the 6 is going to be my adjacent. And the only trig ratio that deals with opposite and adjacent is tangent. So we have tangent of theta equals the opposite over the adjacent. And so if we look at this, we're going to use our calculator, and we're going to set that up by hitting second tangent. So I get tangent -1. I plug in my fraction, and I see that that's going to give me my angle. So on this one, my calculator, second tangent, plug in 10 divided by 6. I get an angle of 59.03 degrees is equal to theta. And that's my answer. That's the missing angle I have there. So we're just using our trig ratios, since they're all kind of similar triangles, that we can use these ratios along with their trig ratio to figure out what the angle is going to be. Okay, so let's go to this one over here. So I've got, let's see, my reference angle's there, so that means that this here is the opposite side. And 17 is on the other side of the right angle, so this is going to be my hypotenuse. And so if I look at my trig ratios, the only one that deals with opposite and hypotenuse is sine. So I have sine of some unknown angle is equal to 6 over 17, because it's opposite over hypotenuse. I'm going to use my calculator to find the inverse of 6 over 17. That'll give me theta. And so on my calculator, I have to do second sine 6 divided by 17, and I get 20.67. Oops. And that's it. So for our little recap, we need to first label the sides as hypotenuse, opposite, or adjacent. I need to choose the right trig ratio. Remember, that's the SOHCAHTOA thing, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is our opposite over adjacent. Then I need to use my calculator to get the inverse trig ratio. And we use the calculator inverse trig ratio, which is using the second button. Then our trig button. And then setting that up by putting either our sine, cosine, tangent, whichever one we're using, to the -1 with our ratio inside of it. So then our fraction, and that's going to give you your angle. Okay? So again, go through the notes, pause at any time, try and keep down, but the big thing is labeling, choosing the right ratio, and then just having the calculator do the work for you. If you have any questions, feel free to email me. Let me know whatever help you need to get. And again, this is the last thing we're going to be doing for the semester. And then we're going to practice on next Monday. And then we'll have our last final quiz on Wednesday. And then it'll just be trying to get grades up and doing like a little project for us all. If you have any questions, again, email me. Let me know what help you need, and I'll be glad to help you.